Welcome back, everybody. Let's open these up and let's see, first off, what the packaging and everything looks like. All right, got our instructions. Okay, looks like the bolts for the battery posts are inside here. I'll just leave them in there for now. The battery came encased in this really good reusable foam that keeps the battery really squared away inside the box, so I give that a thumbs up on the packaging. And as always, it's just amazing how light these lithium batteries are. Okay, so first off, we can see here that we've got two lithium batteries, and they're based on 12.8 volts, where a normal lead-acid 12-volt battery system is based on 12.0. Okay. What LiFePO4 means, okay, is this is the periodic table of elements for lithium, Li, iron, Fe, and phosphate 4. What this actually means is lithium, iron, phosphate. All right, let's take a look at their instructions here. Okay, so the charge voltage is 14.4. The max continuous load is 1280 watts. And the max charging current is 100 amps, and the max discharge current is 100 amps. That's because it's got a 100 amp BMS. But when I have the two tied together, it splits them, so I'll be able to draw actually closer to 200. And look at this, it gives you inverter settings. It tells you where to set everything for your inverter. It tells you on your charger, how to set your charger. The nominal voltage is 12.8, 100 amp hours, 100 amp hours of usable capacity. Recommended charge current is 20 amps. Life cycle is 4,000 cycles. So it looks like discharge range, we can go down to minus 20 degrees Celsius. So my heating system is definitely going to work good. And the great thing about lithium batteries is you don't get a voltage drop like you do with lead acid batteries. In other words, these batteries are probably going to stay above 13.0 until they're down well below 20%, which is just completely awesome. Okay, here it gives you the exact specs for, more detailed specs for an inverter. This tells us at what percentage, what voltage we're going to be at. So yeah, once again, we have to go down below 20% before we drop below 13. That's excellent. And once again here, look, this tells you how to tie your batteries together. Okay, it doesn't matter whether you're connecting in series or in parallel. Okay, notice in the pictures, they're showing you using all equal lengths. Okay, they don't show, you know, two batteries here and two batteries here, or, you know, three batteries here and one battery here. Or they show all the batteries always together the same distance apart, and they always show you running the same length of wire, which is very, very important. And the most important thing, always connect your leads for the load from one end of the system to the other. Okay, you don't attach them both to one battery at one end. Okay, that's just electric 101. And right here they're telling you to do the exact same thing. That's exactly how I'm going to be tying mine together, except I'm only going to have two batteries instead of four. And of course it gives you just some more basic information, telling you about charging, about solar charging, tells you about what to do if the BMS shuts the battery off for safety, anything like that. Gives you an idea of all the different applications. As far as off-grid or for RVs, you cannot beat this battery in this deal.
Oh, kidding. Look at this. That big old battery. Less than 23 pounds. Those batteries outside, 70 pounds a piece. Look at that. Oh, wait, I'm getting a workout here. Maybe I need 4 of them. Anyways.
Each battery came with a spare set of terminal studs, so that's nice. I went ahead and just put these on. Let's go ahead and check the out-of-the-box voltage here. Straight from the manufacturer. All right, got that. And we are looking at, on the first one, 13.28 volts. All right, 13.3 volts. So, yeah, they're not super close, but not super horribly far apart either. So, all right, let's go ahead and get these things charged up, and then we can run some additional tests on them. All right, I've got a 20 amp charger here that is specific for lithium iron phosphate, and it is a 12 volt charger, which is what these batteries are by themselves. So, let's go ahead and hook up the alligator clips, and then plug the charger in. Then we'll come back when these are fully charged and some kind of voltage we've got. All right, this one just came off the charger, and so we need to let this rest for 30 minutes before we take the voltage on that one. The one on the left has been fully rested, so we'll go ahead and check that one out. All right, so now we are reading 13.7 volts. And if we take a look at the manual, you can see here that right there, 13.5 is considered 100%. So we're a little bit over 100%. Right, since this one has actually been done for at least an hour, so we're going to go ahead and do our DC discharge test on this one. Now my tester can't quite get up to 0.2C discharge rate. That would be 20 amps. I'm only able to get up to 13.5 amps because it will shut down on me if I exceed 180 watts. So that's as much as I can pull out of it. I think that's close enough. It should give us pretty representative numbers. Go ahead and check the voltage on this one now that it has rested for 30 minutes. So I'm going to put the leads on here. And we're reading 13.69 volts. So that's only 1/100th lower than this one. Let's see what we ended up with here. Wow, 1,313.75 watt hours. and 104, nearly 104 and a half amp hours. And this is rated for 1280 watt hours and 100 amp hours. So definitely excellent performance out of these very high quality grade A cells that Power Queen is using. So interested to see how this one does. All right, so this one we're starting at 13.5 volts because this one has rested quite a bit longer than this one was when we started the discharge test on this one. So this one was 13.7 as I recall. So we're 0.2 down, and we'll just see what the difference is. Go ahead and dial this up. All right, the one on the right is now done with the discharge test, and we got 1279, so just about 1280 watt hours. So that's right about rated watt hours, and then 109.72, so 102 amp hours. Yeah, so just a little bit less than the one on the left, but we did let this one rest longer, and so when we started the discharge, the starting voltage was just a little bit lower. So it is to be expected that this number would be slightly lower, and still fairly consistently, both of these basically perform at or above spec. When you combine batteries in parallel, you connect the positives to the positives and the negatives to the negatives, and when you do that, you are combining each battery's amp hour capacity, but you're keeping the battery voltage unchanged. So if we connected two 12.8 volt 100 amp hour Power Queen batteries in parallel, we would have a battery bank that has 200 amp hours in capacity being delivered at 12.8 volts, or we also say that as 12 volts nominal. And in contrast, when we combine batteries in series, we are connecting the positive to the negative and then the next positive to the negative and so on. And when we do that, we are combining each battery's voltage, but leaving the amp hour capacity unchanged. So if we again connect our two 12.8 volt 100 amp hour Power Queen batteries in series, we'll have a battery bank that still has 100 amp hours in capacity, but now it's being delivered at 25.6 volts and is what we would call a 24 volt nominal configuration. So what does that mean for total capacity? To calculate capacity, we really want to do that in watt hours. And to get watts, we simply multiply volts times amps equals watts, or volts times amp hours equals watt hours. So taking our 12 volt configuration example, we multiply 12.8 volts times 200 amp hours, and we get a total of 2,560 watt hours. And notice that for our 24 volt configuration, we're multiplying 25.6 volts times only 100 amp hours, and we get 2,560 watt hours. So the total capacity in both configurations is exactly the same. So in this case, we'll need to combine series and parallel connections in the same system. So first we'll put two of our 12.8 volt batteries in parallel to create a 12.8 volt 200 amp hour configuration. And then we'll take our other two batteries and we're going to do exactly the same thing, creating two separate 12.8 volt 200 amp hour battery banks. And then finally, we can connect these two different banks together in series to create one 24 volt nominal 200 amp hour battery bank, giving us a total of 5,120 watt hours while still maintaining our 24 volt nominal configuration. So let's look at 12 volt systems to start with. So in terms of benefits of the 12 volt system, 12 volt systems are directly compatible with 12 volt appliances. So you don't need any converters. You can just connect those 12 volt appliances right up to the system and everything works. These kind of systems are pretty simple and easy to deploy for relatively small solar systems, usually up to, when you're dealing with maybe 600 watts of solar input or less. And finally, another benefit of 12 volt is you can use pretty easy to find 12 volt AC inverters to convert that 12 volts DC into 110 AC. Now let's talk about the benefits and disadvantages of a 24 volt system. So one of the obvious benefits right off the bat is that a 24 volt system will produce half the amperage than a 12 volt system to produce the same amount of power. And half the amperage means you can use a lot less expensive cabling, especially for long cable runs, than you would have to use in a 12 volt system. And that again can be a huge cost savings. Another benefit to 24 volt is that it more easily supports larger solar installations than does 12 volt, using the same charge controller, or as the case may be, fewer charge controllers if you happen to have more than one in the mix. So for example, I have a Bouge RV 40 amp charge controller, and in 12 volt configuration, it can only support up to 600 watts of solar input. But if I change that to a 24 volt system, I can have up to 1200 watts of solar input. And if I go to a 48 volt system, I can have up to 2400 watts of solar input. And if those power needs are under 3000 watts, then you can stick with a parallel battery bank system and that should work for you just fine. Now, if you need to go over 3,000 watts, up to about 6,000 watts, then a 24 volt actually starts to make more sense. And if you're going to go over 6,000 watts, then you probably should be looking at something like a 48 volt system.
I give these batteries a thumbs up, and I cannot wait to install them.